how to find the mean of a grouped frequency distribution. So how do you find the mean of a grouped frequency distribution? The mean here would mean the arithmetic mean, which is denoted by x bar here. And I did say in one of the previous videos that whenever you see x bar, it means mean. Sometimes you may not even see x bar, you may see mu. They mean the same thing. The only difference is that mu is used for the mean of the population, while x bar is used for the sample mean. So to find the sample mean, or for short the mean, when you have a grouped frequency distribution, this is the formula. Though there is another formula that you can use, but since I'm trying to follow the handbook, so let's just stick with this formula. So this is the formula for the mean of a grouped frequency distribution. We have summation fd over n plus m, and as usual, summation would always mean you add up, you sum up, add up all your values. So the question here is, what are you adding up? What are you summing up? We are summing up all the values of fd. So that would mean that there will be such a column called fd that has different data values. So there will be different values for fd, and when we get to the bridge, we'll cross it. After summing up your fd, you divide by your n. Divide by n, and recall that we said that n here simply means summation f. N is the same thing as the sum of your frequency. F means frequency, so n simply means you are adding up all your frequencies, or in other words, the total frequency. And moving on, after dividing your fd by your n, then you add it to m. Right here, what is m? M is a value we call an assumed mean. M means assumed mean. When we go to the example, you see what an assumed mean is. But before we go to the example, there is another formula inside this formula. That is the formula for d. D has its own formula. The formula for d is c minus m. So right here, this d we are referring to is the d from this fd. Okay, so where d, so it means that before you can get fd, before you can put together your fd, you must have first of all gotten your d. And what is our d? Our d is simply c minus m. C minus m. C here means the class center. You know, this time around we are dealing with grouped distribution, or distribution that has classes or groups, and it means we have an interval, an upper limit, or rather a lower limit, all the way to a particular upper limit. But we can't use a class to compute directly. We need a representative of the class, and that representative of the class is usually the class average or the class center. So C here stands for the center of the class. Then we are subtracting it from the m. M here is still the same m we talked about here, which is your assumed mean. So to find your d, or to get your d, or to compute your d, you simply say c minus m. D here actually means deviation from the class center, deviation of the assumed mean from the class center. So this is pretty much all you need to know before you can solve or compute the mean of a grouped frequency distribution. All right, let's walk through an example. So this is an example here. You find this example in page 24 of the handbook, page 24 of the handbook. And over here we have the formula rewritten, still the same formula you saw. X bar equals to summation fd over n plus m. Let the formula guide you, let the formula dictate the direction that you go through. All right, so starting from what the formula says, the formula here says summation fd. That's the first thing you do, the first thing, summation fd. So summation fd means summing up all the values of fd. So it means that you must have first of all gotten fd before summing it up. So you find fd, or you compute fd, and then you sum up fd. And do not forget that we said that to find fd, you must first of all find d, and d as a formula. D is equal to c. This is equals to c minus m. So before you can get d, you must find c. So you find c, m, then get your d, then get your fd before you can get your summation fd. And I did say that c means the class center or class average. Recall that since this is a group distribution, each of the group are referred to as classes. So this is a class, this is another class, this is the third class, the fourth class, until the last class. So these are classes. The groups are called classes. That's one referred to classifications. So the first class is 7 to 12, 7 to 12. And when we are dealing with 7 to 12, the to find your c is equal to the lower class plus the the lower limit plus the upper class limit divided by 2. The lower class limit plus the upper class limit divided by 2. And since we are referring to the first class here, the first class here is 7 to 12. Referring to that first class, 7 would be the lower class limit, while 12 would be the upper class limit. So our first c here would be 7 plus 12 divided by 2. 7 plus 12 divided by 2. If you don't know that, you can always employ your calculator. That will be 7 plus 12 divided by 2, and that is 9.5. So the first class center is 9.5, and you're going to calculate class center for each of the classes. So let me clean this up. Each of the classes, that would mean we are creating a new column. A new column called C. So the first class center, the class center for the first class is 9.5. You do the same for the second class. This is the second class, 13 plus 18 divided by 2. So right here we have 13 plus 18 divided by 2. That is 15.5. 15.5. So you do the same for every other class. We have there 19 plus 24 divided by 2. That should give us 21.5. 25 plus 30 divided by 2. That would be 27.5. This would be 33.5. Here we have 39.5, 45.5, 51.5, and finally we have 51.5. You can pause the video and use your calculator to confirm these values. All right, moving on. We found our C. We've completed our C. You know, the goal is actually to compute D, and before you can compute D, you need C and then M. Now that we found C, the next thing is M. What is our M? Like I said earlier, I said the M is your assumed mean. You assume a particular value to be your mean, then you employ that in your calculation in order to find the actual mean. So we have the actual mean and we have the assumed mean. So M here will serve as the assumed mean, while X bar, by the time you are done or through with your calculations, you can now get the value of your actual mean. So how do you get the assumed mean? To get your assumed mean, all you need to do is to pick a value in your class center column. This is our class center column. I'm referring to this. Usually we pick the value at the center. You know, we have 1 2 3 4 5 6 7 8, and since we have 8, that would mean that we have two center values. This and this would be the two center values, because right here we have 3 up, 3 down. So these are the two center values, and we only need one, but we have two center values. Since we need one, all you need to do is to pick one, and whichever one you pick would be valid. You either pick the first one, 27.5, or you pick the second one, 33.5. Whichever one you pick would be valid. So for this example, I'll be picking the first one, 27.5, and I would suggest that after this video you recalculate or you redo this example using 33.5 as your own assumed mean, and see if you're going to arrive as the same answer as we will be arriving at by the end of this video. So stop the video, or after you've finished watching the video, use 33.5. I'll be using 27.5. You should use 33.5, and then we'll compare our answers. So for my assumed mean, I would be picking 33.5. So that would mean that, so I can just write that up here for reference sake, my assumed mean is 27.5. That is the number I'm picking. Yours should be 33.5. So right here my assumed mean is 27.5. Moving on, we've not still found D. You know, the essence of the O, C and M is to get D, which is the formula we have here. D is C minus M. So now we've found our C, and you know, C's are different values, and then we've also chosen our M. M is just one value, so M here will be regarded as a constant, while C will be regarded as a variable because it changes from class to class. So we can now bring up another column called the D column. So I found a column here called the D column, my column D. So to find column D, we are using this formula, C minus M. Well, this is our first C, this is our M. Our M remains the same, it doesn't change. The only thing that changes are the C, because the C for the first class is 9.5, the C for the second class is 15.5, 21.5, and so on and so forth. So C keeps changing. C is a variable, M doesn't change, M is a constant. We have just one assumed mean. So let's compute our D. So the first D would be C minus M, which is 9.5 minus our 27.5. Then you can bring up your calculator. So here we have 9.5 please. Let's see. All right, 9.5 minus 27.5, and that is 18. So let me bring this over here. So our first D is negative 18. The next one is 15.5 minus the same value, the same as we made, 27.5. Okay, this is minus 18. Then the next one is minus 12. Then the next C is 21.5 minus the same 27.5. Here we have minus 6. Then you move on again, 27.5 minus the same 27.5, that's 0. Then we have 3.5 minus our constant, 27.5. 27.5. So that's 6. So I'm just going to skip the calculation and fill it up. Here we have 12, 18, and 24. Okay, moving on. Now we've gotten our D. Let's go back to the formula. Remember, the formula dictates your steps or your direction. So the formula says summation FD, but before you can find summation FD, you need FD first. So we need another column called the FD column. So here we have the FD column, and FD simply means F times D. So you're multiplying all the F's by all the D's. It means these are our F's and these are the D's. So for the first FD would be the first F, which is 3, times the first D minus 18. Then you go on to say again 7 times minus 12, and you move on like that. So the calculator is your best friend. That is my best friend. So for the first F, I have 3 times minus 18. That is negative 54. The next one is 7 and minus 12. So we have 7 times minus 12, we have negative 84. Moving on again, we have 7 times minus 6, so this is negative 42. So I'm going to skip the calculations and then just populate the column. So this is 0, 60, 60, 36, and 48. Now that has been filled down, let's go back to our formula. Our formula says summation FD. So the first thing we are looking for is the sum of all the values under the FD columns. So let's sum that up. My best friends there. So you're summing all the FD values. Don't forget, these are your FD values. Alright, so the first value there is negative 54 plus minus 84 plus minus 42. As you can see there, we have plus 0, so let's just add that. Plus 60 plus 60 plus 36 plus 48. Altogether, we have 24. that's done. Going back to the formula, after we found summation FD, the next thing is to find N. And do not forget that N is equal to summation F. Never forget that. Summation F means summation of all the values in the F column, or total frequencies. So let's do that. So we sum up all the frequency values. This will be 3.7 plus 7 plus 14 plus 10 plus 5 plus 2 plus 2. Altogether we have 50. Altogether we have 50. Okay, back to our formula. So we found this. The next thing is our M. Our M remains the same. Do not forget I said it's a constant that we chose from here. While practicing this, your M should be this value, but for this example, this is mine over here. I've chosen this one and I've written it out here to signify that is my M. So moving on, we can then apply the formula. I think we have all we need. We have summation FD here, we have our N, and then we have our M. Then we can find X bar. So X bar is equals to summation FD, which is 24, divided by our N, 50, plus our M, 27.5. So way to go. 24 divided by 50 plus 27.5. Our mean is 27.98. As easy as that. So that is our final answer, and I expect that by the time you are practicing this example using this as your assumed mean, you should get this also as your sample mean.